Hello and welcome, fair residents of Jefferson County and beyond. Welcome to the 2021 virtual Jefferson County Fair. My name is Sam, and my magic name is Alakazam, and I am a magician and a science educator. I've been doing magic for some 48 years now, ever since I was born, and I've also been a science teacher for, well, more than 30 years. And a kind of stick that magicians use to make their magic happen. They wave it around and tap things. What's that thing called? Yes, a magic wand. I'll be using wands throughout the videos this weekend, starting with this a classic black and white wand. Now, this first science magic trick I'm going to show you is one you may have seen before. You may well have performed it before because it's a very popular science magic trick. However, I promise a very magical and surprising ending to this, my version of the water suspension trick. And this, as I said, is the classic science magic trick that you may have seen or done before, where you can take a jar or a glass of water, and with a card that's bigger than the mouth of the jar, put it over the top, and doing this over a sink or a basin, you may be able to practice to invert the jar, turn it over, and let go. And now the water really is being suspended, just hanging there. Now, what do you at home predict would happen if I were to pull the card away? Yeah, you think so? Let's check your prediction. Ah! You are right. When I removed the card, the water came racing out. Now that, as I said, is the classic science water suspension, but I've got a more magical version for you, because we're going to use not just some water, we're going to use a lot of water. With this jar of heavy water and a card over the top, watch as Alakazam inverts the jar, and magically the water stays suspended. But wait, there's more. Here's the surprising ending, because now I can take the card off and the water stays suspended, just hanging there. No wires, no magnets, no hidden suction cups. How was the water staying suspended? Well, I, as the amazing Alakazam, can also get the water to come out on my command. All I have to do is wave my wand, a 1, 2, 3, Alakazam, and the water comes gushing out of. What's the secret to why the water stays up? What explains it? To explain the first one, the classic science trick where you can put a card over the top and invert it and get the water to stay up there with the card, an explanation for that includes what this room is full of. Something invisible that I'm passing my hand through. Yeah, air. The room I'm in has air. The room you're in has air. And thank goodness, right? Because air has in it the oxygen that we need to breathe. Well, air, although invisible, it takes up space and it has volume. And it's the air in the room that actually helps hold the water up. Because if you put a small volume of water in here and place a card over the top, as I described, and invert it, or over a sink or a basin, it'll stay there, partly because the air in the room is creating air pressure that holds the card in place. But we saw what happens when you take the card away, the water comes pouring out. Say, let's take a closer look at the props I used to see if we can figure out the science secret behind Alakazam's water suspension. Do you believe that the secret is held in the wand? Is that what made the magic happen? Maybe not. In this case, it was just a prop. How about the jar? What if we take a closer look at the jar that I used for that demonstration? What do you observe? There's something on the lid of that jar. What is it? It's a piece of house screen. It looks like mesh or netting, but it's a piece of window screening. Yeah, what I did is I used waterproof glue to attach this bit of window screening to the top of the jar. And do you see how water is sticking in many of the holes of the screen? Yeah, that's because of a property of water known as surface tension. Water has a kind of film or a skin that naturally forms. It's because of how the H2O molecules, the water molecules, interact, especially those hydrogen atoms. They create a kind of skin or film on the surface of water that, in the case of the film in each of those little screen holes, it's a force that helps hold the water up. So the secret to the water suspension is that window screening helped provide the surface tension that helped overcome the force of gravity. So between air in the room and the surface tension in all the screen holes, the water was held up. Here, that secretly, there's a piece of screening attached to the top of the jar. I'll show you what can help sell it. Now, since there's screening in there, and you don't show the audience, but you can pour water through the screen into the jar. That demonstration creates the powerful illusion of an open jar. Well, if you take the card and place the card over the top, and once again invert it, air pressure in the room, invisible air, is helping to hold that card up. But what keeps the water from falling out is surface tension in all of those little screen holes underneath there. Now, did anyone notice what it was I did earlier to get the water to come out, to get it to fall out? Yeah, I tipped the jar a little bit, and I'll tip it this time towards the audience. Usually I tip the jar away from the audience so they might not see the screen. But let's release the water by going 1, 2, 3, alakazam. And when you tip it, the water piles up, the force of gravity becomes greater than surface tension and air pressure in the room, and the water comes racing out. Should you want to make your own water suspension trick, I'll tell you how you might go about it. Now, you don't have to use waterproof glue with the screening on here. And another idea is if you have one of those canning jars, you know those jars that have the inserts that you can leave out? Well, what I've done here is I put some screening over the top of the empty jar, and then I screwed just the rim part on here and then trimmed off the extra screening to make what will work as the water suspension trick. You can do that same trick with this kind of setup. And coming by screening, it's easy. I've got advice on that too. What you need to do, kids, is to get a really big, sharp pair of scissors, and you go find a window in your house that has a screen, and you cut a big hole. No, don't do that. What was I thinking? You'll get in trouble if you cut the screen. Don't do that. Here, better idea. What you do is you take those really sharp scissors that you got, and you go over to a neighbor's house. Yes, go to a neighbor's house. Cut the window screening from... No. Don't do that either. That's a bad idea. What am I thinking? Alakazam. Don't. You can buy window screening at a hardware store. That's where you could get some screening. Or if you happen to have a broken screen laying around, you might have some scrap screening on that broken one that you can make one of your own with. We're going to start with observations. What do I have here? What do you think these are? Beads, marbles, blueberries, magnetic marbles. Well, magnetic marbles are cool because they will stick together and form a chain if the magnet is strong enough. But these are not magnetic, they're beads. They're plastic beads on a chain, on one continuous chain. This chain of beads here is 12 meters long. How many beads do you think are in this container? What's your guess, your estimate? It's always good to be willing to make estimates or guesses or predictions. It's a big part of math, a big part of science. So I'm going to give you and your family some time now to guess how many beads you think are in here, and I will reveal shortly. But first I want to explain that the 12 meters of beads in here were put in here neatly so they're not tangled. In a moment I'm going to ask you to make a prediction. And that is, what do you think would happen if I pulled on the end of the beads? These red ones represent the end of the chain. What do you think might happen if I pulled out a length of chain and then let it go? Any predictions, any guesses what you think's going to happen? And when it comes to mathematics and when we make guesses, it's called an estimate. And our estimates can get better with more information. In fact, you'll have chances to make even more estimates. This container had 1,360 beads in one continuous strand. And what about those predictions? When it comes to science, when we make guesses, it's known as a prediction or a hypothesis. What was your prediction for what would happen if I pulled out a length of beads and let it go? Well, let's check those predictions by doing the science. This demonstration looks a little better against a light background. So I'll move this over and let's watch what happens when I pull out a length and let it go. What? Did you expect that? Perhaps unexpected. Maybe you've seen it before. Maybe you predicted that was going to happen. But once it got started, it just kept going and going. And not only that, but did you notice the beads rising up out of the container? Yeah, that's what I think is most magical about this demonstration. The beads, they seem to rise up. It's what magicians call a levitation. When you make an object or a person float, you are levitating them. Well, for me, these beads seem to be levitating. And that magic can be explained with science. Yes, this container has still more beads. And I will invite you to once again make an estimate, a guess. Now, this smaller container had 1,360 beads, and it wasn't but half full. So what do you think this larger container contains? Again, ready? Here it goes. Oh, that's a good one. Rise. Oh, there you have it. And those watching closely at home could have also detected how many beads were in this container. Forgot to show you. This container had 4,080 beads. So any of you who bumped your estimates up, you're doing a good job estimating. There were definitely more in this bigger container. And did you see once again the rising of the beads? What explains that? Why? How is it that they rise up? Well, to better understand the science behind that, it's some physics. And gravity's involved, and Sir Isaac Newton is involved. Yeah, Sir Isaac Newton was a famous early scientist who studied gravity, amongst other things. And he also figured out how things move and why they move. And Newton came up with some laws of motion. And his third law of motion states that for every action, there's an equal and opposite reaction. Maybe you've heard people say this, but for every force, there's an equal and opposite force, or something like that. It's not just an expression, it's a law. It's Newton's third law of motion. And what he's saying is that anytime a force is exerted someplace, there's an equal and opposite force that happens at the same time. Well, what's going on with the beads? These beads, due to gravity pulling the chain down, it causes the beads to be pulled out. Well, when they get pulled out or get pulled up, as it were, there's also a force of the beads pushing down. That's the equal and opposite force that Newton was talking about. So the upwards force is coupled with the downwards force. That downwards force should make the container of beads go down, move down. That's where the force is going. But I don't let it go. I hold it in place with my muscles. And that downwards force, it's transferred into an upwards force that causes the beads to rise up and arch out of the container. So that rising up is due to Newton's third law of motion. For every action, there's an equal and opposite reaction. It also explains why some skateboard tricks work. Yeah, saw skateboarding join the Olympics this year. When they do an ollie, when they kick the back of the skateboard down, what direction does that make the skater go? Yeah, it makes her go up. And so what's happening with the skateboard, when the back of the board hits the earth, there's an equal and opposite force pushing down, but the earth is too big. It won't budge. And so that downwards force gets transferred into an upwards force that makes the skateboard leap. I've got more beads in this container. This container has one strand of beads. Now these are metal beads. They're even smaller than those plastic ones. And this gold chain is in here neatly, followed by and attached to this silver chain. So this is one strand of beads, 61 meters long. How many beads do you think are in here? Make your guesses about the total number of beads filling this container. Now this demonstration of the chain siphon, I think it shows up a little better against the dark background. So I'll move the curtain back for that effect. And here's final guesses. How many beads do you think there were? In here, there are 9,800 beads. Anyway, if you guessed 10,000, you weren't but 200 off. In any case, a lot of beads. 9,800 beads. Let's watch this big final demonstration of the chain siphon at the 2021 Virtual Jefferson County Fair. Here it goes. A little tangle, but that's all right because we're rising. Oh, that's a good one. It's science and magic in motion. There you have it, ladies and gentlemen. The Chain Siphon by Alakazam. Hey, thank you so much for joining me today, and I look forward to seeing you again when we do more Science and Magic by Alakazam. Brought to you by the Jefferson County Fair.